for this technical problems. Okay, can you hear my presentation? Or can you see it? Other?
Yes, we can see it. Thank you.
Okay, all right. So I'll try and make a quick start now that we're a few minutes late. So hi everyone who decided to join this session. My name is Davorin. I currently work at the University Computing Center in Croatia. A bit about myself, I've been dealing with Informix in one way or another for the past 18 years. The first few years I've spent as a software developer, and the rest of my Informix career I've spent as an Informix DBA. In the last few years, I've picked up a few DevOps skills, and this is basically how this presentation is going to be. There isn't an awful lot of Informix in it. It's more about the tools surrounding it. The company that I work for is an ICT infrastructure and service provider. We've been using Informix for over 20 years, of course, for its mission-critical systems. In this presentation, I'll try and cover the most important aspects of the database-related DevOps practices we use within the company. This includes the description how Informix was handled historically in this and pretty much all other companies that I worked for so far. The main motivation to start evolving that setup, and the most important tools we used and how we implemented them. And of course, how it all fits together within the company. My rough estimate is that we're only halfway there. There is still a lot missing, but it's all being actively worked on. So while initially researching the field of database DevOps a year or so ago, we've come across a few similar terms, and each of them had their own explanation. The differences were mainly revolving around naming, which was of very little importance to us. The other questions raised were whether it's applicable only to analytics and reporting. Is it something that only sysadmins should do, or should it follow GitOps principles? I'm guessing the main question was, is it just a fancy name for automation? We chose the term database operations, and we also came up with our own wish list of what is it and what we want from it. The main objectives being applying DevOps principles and tools in our day-to-day database operations, delegate at least some of the DBA workload to developers, but without requiring them to need to know the database internals. And all that while maintaining security aspects. We didn't get to implement everything. The bonus features are still on our to-do list. A few more details about the company. It's approximately 150 employees, and this year we had a 50-year anniversary. It is the provider of the IT infrastructure for the whole of Croatian scientific and higher education landscape. The team that I currently work for is approximately 30 employees, designing, developing, and supporting information systems for higher education and science. This mainly consists of large bespoke systems written in Java. It's a mixture of desktop and web applications. We also have reporting and analytics systems, the old one using Microsoft technologies, and the new one using R, statistical and computational language with its modules for producing shiny web-based reports. We are a very diverse team of people. There are a number of teams, starting with the virtualization team, sysadmins, backup admins, Java developers, both for desktop and web applications, R developers and analysts, and so far we only have a single DevOps guy. Because of all the diversity, we really had to have common tools and interfaces for all our teams so we can communicate effectively with each other. We're a pretty traditional company as well. We don't do cloud native yet. That's still to come. Most of our servers are virtual machines, actually. We only have a handful of Dockerized services, but that's all manual, so automation didn't get us that far yet. Between the people within the company who are Informix savvy, we probably have more than 100 engineer years of Informix expertise. There are a lot of existing scripts, so from various authors using various approaches. Obviously, we wanted to reuse all of that. We are heavy users of Art's utilities, but there are also many in-house built scripts, mainly shell scripts invoked via cron. This all had to be exposed through a common interface. There were already security mechanisms in place which we had to abide by. They were pretty traditional and standard Unix permissions and sudo rules to allow people onto the machines and to deal with the software installed within them. One of the main requirements as well was to visualize our workflows through standard tools. And all this in hope to break up knowledge silos, which are inherent to the company organization, and to develop new organizational workflows. While we were deciding on which tools to use, we've set up a few requirements. Ideally, we wanted to use the tools which are already in use within the company, because we wanted to have a tool expert at hand, at least in the beginning, while we were starting with the whole thing. The tools had to be free and open wherever possible, but even more importantly, accepted and in production used by big players in IT industry. Good documentation and community support as well, and a first-class support for Linux. We do have some Windows and proprietary Unix server-side installs, but that's all gradually fading out, and eventually it will all be replaced by Linux sooner rather than later. All the tools had to support a configuration as a code paradigm in a declarative rather than imperative way. So in the end, we ended up with the following tool set. The virtual machine creation is being done by the VMware virtualization platform. That's probably the only tool that we didn't get to automate. That's still all done manually. But the next one on the list, Cobbler, the virtual machine installation tool, that's open source. Same as Puppet, used for configuring the virtual machines. Once we have the virtual machine up and running, it's time to get Informix instance up and running on it. To do that, we also use Puppet, but rather than reusing the built-in functionality within it, we wrote our own in-house Puppet manifests to deal with Informix. In the next step, once we have the Informix instance, we want to deal with it, manage the instance, and manage the databases contained with this instance. So what so far, we were using Bolt, which is a standalone tool developed as a part of Puppet but can be used as is. We use it to stop, start, restart, and read logs from an Informix instance. We use it to support database level operations, from the most basic ones like running SQL scripts or ad hoc queries, which are the building blocks to support the ETL processes that we do in a scripted manner, to the more complex, like copying the database from one instance to another and building the databases from source code in our Git repositories. At the end of all this, we also wanted to coordinate between all the activities and visualize the low-level operations that I've just described. And to do that, we use the GitLab tool. I will do one slide introduction to each of the tools only. all of them have an excellent documentation. There's no need to repeat it here. So Cobbler is a Linux installation server. It allows for rapid setup when rolling out new systems or changing the existing ones. It does everything that it says here on this slide, but we mainly use it for base operating system installs. It does have its GUI. Doesn't really look like Web 2.0, but it's not about the GUI anyway. This is what it's about. So to see it in action, actually I didn't write this slide myself. My sysadmin colleague helped me with this. But basically what it boils down to is after we create a virtual machine on VMware, it just takes this first block of code, Cobbler system, to install the operating system, at least its basics. So the green bit, the host name, is picked by a development team following certain naming conventions. And then the networking configuration is provided by the virtualization team after creating the virtual machine. And that's basically all it takes to install the OS. What this defines as well is a profile. Profile pretty much says which flavor of operating system it is and its version, and also kickstart script needed to install it. That's a standard way sysadmins install their OSs. The distribution, all that it defines is basically a DVD ISO image needed to kick off the install. Once you hit enter, you have the virtual machine installed with a fresh operating system. Once that's done, most of the virtual machines look identical, except obviously for the networking setup. But since each and every virtual machine plays a different role, they require configuration which can differ greatly from one virtual machine to another. Puppet is the tool to do that. So to configure all aspects of the operating system, stuff like configuring frequently used software like Apache or Java or Docker. There are out-of-the-box modules to do that in Puppet, but it also provides a development kit enabling anyone to write additional modules. And currently, there's more than 1,000 modules on Puppet Forge. That's a catalog of modules that's both supported and built in and community provided. The way that Puppet does it, it's using a desired state configuration. So basically you tell it what you want the system to look like, and then Puppet does the rest. It's server agent architecture based, and it's using declarative domain specific language. It has all the attributes of similar other systems like Ansible. So getting Informix instance up and running boils down to IDS install, which is still done manually, and then just choosing the instance name and updating it in the on-config. After that, once Puppet agent is run on the virtual machine, everything else is automatic. That includes PAM configuration. We're heavy LDAP users for user authentication. All the operating system package dependencies needed for proper Informix functioning, like AIO libraries, shell interpreters, and so on. All the users and groups that we need on the database server, various directories that need to be created. We have a habit of separating out configuration, logs, and data. Our data is being preserved in cooked files rather than raw devices for simplicity. Further on, we also create all the configuration and environment files needed. All the Informix environment variables, except for the locales, are contained in etc profile D script. SQL hosts file is also created by Puppet, and systemd unit files as well. Probably the biggest pain point of the whole Informix setup on each virtual machine is setting up backup and archive. We're using Tivoli Storage Manager, and setting up all its policies and environments usually takes time, and it's very error prone, and we've solved all that with using Puppet. This is what those custom written Puppet manifests look like. They use Ruby-like syntax, and as you can see, it's very easy to read and write. The includes that you can see at the top are very simple built-in manifests for standard sysadmin type of operations like adding users and groups. And the red line is the only input parameter that we require to set up an instance. This is stored internally within the Puppet database called Hiera. And from then on, it's either static configuration within the manifest or templates with simple placeholders using this instance name that we've set up. A couple of examples, /etc/Informix directory. So the configuration directory is set up this way, and also the etc profile D script. As you can see, it's using a template rather than being hard-coded. And this template is shown at the bottom of this slide. It's all standard content, just Informix environment variables with just one difference. There's a placeholder for the instance name that we've just specified in this Puppet internal database. Once that template has been instantiated, it provides the complete Informix environment, both the server needs and all the clients using DB access while logging onto the system. The reason why we chose etc profile D sh file is because that's a standard Linux approach these days. And this way, it's that easy for anyone with the access to the virtual machine and appropriate permissions to figure out the Informix setup. Systemd wrapper scripts are defined in a very similar way, and they also depend on the templated environment, as you can see. And any additional OS packages are defined here as well. So we have the virtual machine up and running. Now we want to do something with it. The tool to do that is Bolt. It's a tool produced by the same Puppet team, but it can be used standalone. It's a very simple tool. It's agentless, and it's inventory-based. That means it just needs one simple file with all the targets and hosts and potentially their groupings, and that's pretty much it. Doesn't take any other input to enable its functioning. What is it good at? It's best in enabling of reusing the existing scripts. It doesn't really care what is it that you try to run, as long as you can run it on a target virtual machine or node. It's using a hierarchy of action objects which build on top of each other. The most basic ones are commands, which are then used by tasks and further on by plans. What do we use it for? As I said, so we manage instances by using Puppet tasks and plans and the database level operations. I'm going to show you a few examples of those. Some of them are really simple ones, and obviously the more complex ones couldn't fit into presentations, so I didn't bother copying them in. This is just a quick glance at our setup. So this is the inventory shown. Currently, there is around 15 target nodes, which are all virtual machines. What you can see under the targets here are actually target aliases, and they're fully qualified. The main names are actually stored within the inventory file, but it's much easier to refer to them using aliases, so that's what we're doing. All of them can be grouped in an arbitrary way. The group hierarchy that we came up with is here. So obviously applications and databases, and on different environments like dev, test, and production. Once we roll out Bolt to all the virtual machines that we want to be handled by it, there should be approximately 100 targets once the whole company application portfolio has been included. So the hierarchy of actions applicable to those targets and groups consist of commands. These are the most basic ones, so you can run simple commands on either a single target or a group of targets. Say, like in this example, you can run any command supported by the target. If you want it multiple times, then you just specify a target group. Commands are then utilized as building blocks for tasks. These are higher level construct, but still simple enough. Each of them does one and only one simple operation, like creating a database, renaming it, or running a SQL script or an ad hoc query, that kind of stuff. And the highest level of abstraction in Bolt is implemented using plans. Now, plans represent complex workflows. They're composed of commands and tasks, both built-in and custom-written. And they can be easily integrated into workflow coordinators, such as continuous integration environments like Jenkins and GitLab. This is an example of the most frequently used task. We call it Transcript. All it does is it runs a specified SQL script on a specified database. The task documentation that you can see here is a very simple JSON list of parameters and their descriptions, including the data types and default values, if any. And the task implementation can be anything that can be run on a target. In this case, it's a shell script, and a simple one as well. But it can be a binary or a Perl script or anything else that you already have and want to reuse this way. The security rules that we've already had in place, we didn't want to reinvent the wheel in this aspect as well. We just recaptured them within the task implementation. So this task is obviously using sudo to do what it's required to do. And obviously, if a person doesn't have sudoers rules set up, the task will fail, as it should. One detail that I wanted to show is how simple is it to translate Informix specific features into higher level configuration items, which are more readable to users with no or little Informix exposure. So the parameter fail fast, which is a Boolean value, is really a somewhat cryptic environment variable used in DB access, so DBA-CC no IGN, allowing a script to continue or fail in case, or fail immediately in case of a failure of a single SQL statement contained with it. So not everyone is knowledgeable about the DB access and the server side of Informix, but anyone can guess what a fail fast, true or false means. Now for the two very simple tasks. The first one being just showing the last lines of online log, and the second one being a database instance restart. And you can ask, why am I showing such trivial tasks? But they're only trivial if you're an Informix DBA, and not everyone in the company is Informix DBA. We have a lot of developers, and they should all be able to do stuff like this at any time. Well, except on production, of course. And if you remember on the previous slide, we had a task to run an arbitrary SQL script, which is inherently a database owner task. And here on this slide, we have a database server administrator task of checking the Informix log and a sysadmin task of restarting the systemd service. And they're all using the same automation framework with a consistent interface. This is what we believe to be Bolt's biggest advantage and strength. Plans are the highest level Bolt concepts. They run and connect individual commands and tasks. The one shown here is the simplest and shortest plan we have. It's barely 20 lines of simple YAML code, which I'll show you on the next slide. Similar to tasks, it's self-documented. We do have other plans, which are a lot more complex, consisting of hundreds of lines of YAML. Some of them build databases from scratch from our Git database code repository. Others are making dirty exports of databases from one instance to another, mainly used by developers to create their own private database copies without any help from the DBA, that is. This is a plan documentation, plain and simple. It's just a description, a list of parameters, their data types, and the default values, if there are any. And this is a plan implementation. It's a series of simple YAML instructions. Here you can see an example of running standalone commands, evaluating their return values, and then using built-in tasks like file uploads, and also using user-defined task that we've just seen a moment ago, so run script. It's a very simple plan. Just to quickly go through it, we get the message out, we generate a timestamp to use as a pseudo-random number generator. We upload a SQL file with that random name to the database server, and then we just run it on a specified database and clean up afterwards. Even though it's so simple, it's of great use, which I'll be showing you on later slides. All of this has to be coordinated and visualized in some way. We decided to use GitLab. GitLab is an integrated development platform, not just a tool, but the whole platform. It's huge. It deserves not just its own presentation, but the whole conference. And actually, there was one 2 months ago. One of the best features of it, it's language neutral. It supports many programming languages, and any of them can be used efficiently with GitLab. Most of its features are either included in a free version from the beginning, or they become available after a few major releases of a paid version. The screenshot here shows a pipeline run report. As you can see, there are some failures, but it's mostly success. And such pipelines are normally triggered each time a Git repository with the database code gets updated. That goes for the main branch only, though. GitLab itself also follows configuration as a code paradigm. And again, just like Puppet and Bolt, it's simple YAML file with easily readable syntax. Each pipeline defines elements such as Docker images used for the pipeline run, included pipeline templates and fragments, user-defined variables, stages and job definitions, and build artifacts to save and use in subsequent jobs. Here you can see a setup job, which pretty much all it does, it makes environment variables and contents of Git repository with built utilities available to subsequent stages and jobs. GitLab continuous integration pipelines also have a concept of template jobs, which are themselves reusable elements in proper GitLab jobs. They're all prefixed with a dot. So basically, these are scripts defining workflows. Most important lines on this slide are in bold. And as you can see, they're using previously defined bold tasks and plans. So just to quickly run through that. This shows our ETL process, which consists of creating a copy or a mirror of an OLTP database, and then recreating an analytical database from scratch. Then it's just a series of ETL scripts, one after another, and at the very end, we're creating synonyms and permissions on the database, and that's all it takes to have a fully built analytical database. Once that's done, we have to load it with the data, which is again done by a template job, reusing the same bolt plans as previously. These are the real jobs here, and they're similarly named because they do exactly the same thing, but on different environments. In this case, development and production environment. Well, all they do is basically extend and reuse previously defined template jobs that we've just seen, but also injecting their own variable values specific for those different environments. They can also potentially define what are the triggers, if it's a timed schedule or if it's one of the event-based runs, with events being git push or merge or manual pipeline kickoff. One of the most unavoidable buzzwords in the DevOps world being observability. And in fact, our preferred solution was to use Prometheus in Grafana, but even though there is an Informix Prometheus exporter, we found it not to be scalable because it forks DB access process for each of the metrics collected, which can be tens or even hundreds. And we figured out that writing our own Prometheus exporter was too much work. I believe I've seen a session on this subject, so I guess I have to check out if anything changed in the meantime, because we'd be quite glad to start using this approach. But instead we turned to IBM, and IBM finally released a good tool to monitor Informix some time ago. It works really well out of the box on version 14.10, but it's also running pretty well on our 12.10 instances too. Each newly set up Informix virtual machine and instance gets included in Informix HQ by default. The tool is not as polished as we hoped. There are search and filtering capabilities missing on some of the screens, but it gets better and better with each release. We're currently test driving the 14.10 XE5 version without any major issues. So I guess at this stage, I'd have to thank IBM for making it happen after using unperf tool and open admin tool for years. This is pure delight. HQ install and configuration like IDS is semi-automated at the moment. The agent side of it is fully configured by Puppet, and that consists of a systemd service unit, so we can enable automatic restarts after virtual machine reboots. But the server side is still manual, so each Informix instance gets added manually. Now, the plan is, after migrating all our instances to version 14.10, everything should be automated, even the server side. It's probably worth noting that having different Informix version doesn't really help with any kind of automation. And of course, Informix is not on its own. The standard stack we support consists of web layer, usually implemented by either Apache or HA proxy, applications written either in Java or R, and then very recently from a Docker Swarm backend introduced as a cluster management solution with only a handful of applications using it at the moment. Because of that, we've developed a number of bold tasks and plans to deal with both application, web layer, and a Docker backend side of things. So we have a few, but just to give you an idea what they do, here are a few simplest ones, one from each layer. So the first one being showing an application status. One thing I haven't shown before is that the task implementations can either use input formatted as simple environment variables, or if it's more complex than that, it can be a JSON formatted input document. It can be as complex as you need it. And on the server side, it's usually parsed by the JQ tool. The other two examples show two styles of service reloads we normally do. One is just standard systemd based for web reloads, and the other one being a specific command, such as the one coming from Docker, to enable application developers to restart their Docker services without any further intervention from any of the sysadmins. roughly speaking, when it comes to automation of all things Informix within the company, we think we're halfway there. There is still a lot to tackle. The main items being shown here, we do Informix installs manually still. What we'd like to do is really to extract the package in a legacy mode, tar it up, and store within the Cobbler repository, similar to what we do to the operating system ISO images. Then once the virtual machine creating and configuration process kicks off, we'd just untar it and run as root script and have a fully functioning Informix binaries installed. The next item would be the onConfig templating. Even now, more than 90% of the onConfig content that we use is identical between all the instances. Now, obviously, the instance name will be different in all the DB server aliases, but this can also be templated just by providing that one simple input variable, the instance name, and then the rest stays the same. Now, obviously, not every virtual machine has the same processing power, so the number of CPUs, so the amount of memory that would have to be done manually later on by a knowledgeable DBA, but still, I'd say at least 90% of the onConfig content is always the same, so it could easily be automated. The Informix HQ, we don't use any of the internal users like Informix or any other application related. We have a specific user, we call it HQ, obviously, and it's set up manually at the moment. Even the account creation and all the access rules, so connecting to sys user, sysmaster, and sysadmin, and all the other user-created databases, that's all done manually. We have a recipe, so it's almost scripted already. It would be very easy to put it into Bolt and just use one of the appropriate tasks to do it rather than running all the SQL manually each time. One of the biggest items we haven't touched yet is release and schema management. The way we do it currently is completely manual and pretty crude. We accumulate all the production schema and data changes in a single SQL script. We then take the application downtime if needed, which is rarely the case, but sometimes we just have to do it. And we apply the whole SQL script in one go. Then we flush it, delete all the content, and start over until the next release. Now, we were looking at the automation tools out there. There are quite a few in the Java development world, the two most prominent ones being Liquibase and Flyway. But these are pretty heavyweight solutions, and they require many changes to our development lifecycle. So that's not something that we'd easily put in. We're rather debating whether we can use the existing infrastructure, such as Puppet and Bolt, to do it for us. There's always minor stuff that we'd like to have. For example, if you're using different Informix editions, not all features will work on lesser editions, like, say, Innovator C. For example, table fragmentation will not work on it. So if you want to automatically copy the database or a single table which is using fragmentation, that has to be removed in one way or another. So that's something that's still to be done. Also, one of the plans is to buy perhaps Puppet Enterprise, which is a web GUI for Puppet tool, which enables everyone to just point and click within a browser rather than using the command line. We're not afraid of command line, but it's much nicer to look at a nice GUI than go through terminal every time. But that costs some money, so that's still not being implemented at the moment. And last thing is, what did we gain by all this? We've cut down time needed to do the chores significantly. So we're talking minutes now instead of hours, sometimes even days if things don't go as planned. we have the most complex database workload visualized. There is a growing sense that everyone can be a DBA nowadays. Now, whether that's true or not, that's debatable. But at least everyone feels happy about it. We've managed to reuse the tools that the company was already using for completely different use cases that weren't planned in the beginning. All these tools are used by and trusted by big names in the IT industry, and they turned out to be really simple to extend. Everyone reads and writes simple YAML and shell scripts. And because our developers work across a very diverse set of technologies, we had to find a way somehow to give them a unified experience rather than requiring them to know all those different technologies, which are not directly software development related. We're just giving them tools to use them without knowing what's exactly happening under the bonnet. The main point for me, being a DBA, is that we've managed to start treating the database code in the same way that we treat our application code. So all our database code is being constantly tested. Each and every Git push or merge to the Git repository main branch kicks off a pipeline. The pipeline tries to build a new database from scratch using all the SQL scripts contained within the Git repository. And if it fails for any reason, we get instant notifications. Whoever pushed the commit that broke the pipeline is required to take a look at it and fix it as soon as possible. At the end of the day, this enabled us to onboard the new developers much quicker than before. We've also managed to break down quite a few knowledge silos which were inherent to the company structure and gave our developers a sense of ownership of the systems that they develop and support. That's it from me. I'm happy to take any questions.
If you have any questions, you can put them in the chat, but I didn't see any yet. And if we don't have any questions, we'll just thank Dvorin and appreciate you coming to talk to us.
Sorry for the technical issues we had at the beginning, but hopefully this is all fine now. Goodbye, everyone.
Thank you.